Good morning, everybody, and thank you for taking the time to attend our webinar on fixing assembly errors. Very quick rundown of a couple of things. We will be recording the video. As you see, the message has popped up there, and it will be available on YouTube afterwards. Please ask any questions that you have in the Q&A. And please participate in the poll when prompted to at the end of the presentation. We'd really value your feedback. We'd love to improve on what we're doing, which is why we want the poll results there. Very quick agenda, just some introductions, a short discussion on why it's really important to fix assembly failures. Very often they just go ignored. And then Reginald is going to go through some common failures that do crop up in assemblies, and he's going to show us how to fix some of those, and then there's going to be obviously an opportunity for some Q&A at the end. All right, so the burning question, why fix failures? And I'm adding here as soon as they arise. We've all seen that little red flag at the bottom of our assembly dialog of assembly screens at the point in time, hopefully with not such a high number next to it, okay, but this does come from a very large assembly. But you can imagine the amount of time it would take to go through and now and go and fix 120 failures in an assembly. So what can these failures and errors give us? Sometimes it gives us unexpected behavior in a model, and very often from a circular reference, you'll see a part when you regenerate your assembly, a part is sitting in one position, and when you regenerate it again, it's sitting in a different position, and then you regenerate it again, and it goes back to the other position. Very often caused by circular references, obviously resulting in incorrect models that could be leaving the office. Another message to look out for, assembly cut entirely outside the model. This doesn't necessarily come up as an error, but as a message. But it is worth checking, and sometimes it actually is a valid cut still. We can go into more explanation on that if anybody has any questions about that. But it is worth understanding where that message is coming from, because it could mean that you have an incorrect model. If your assembly or part is not able to update and regenerate correctly and through the entire assembly, you can have relations, your post-regeneration relations, that are not up to date, and that obviously can result in parameters not being up to date as well in your models. Furthermore, if you're working in Windchill, you can have check-in errors where your check-in could be entirely blocked. Sometimes it's a publishing failure, so you're not getting the correct information out. We've had instances where the WT structures are not updating correctly just because the assembly has not actually been completely regenerated before being checked into Windchill. So just back to the little movie that we watched previously, A Stitch in Time Saves Nine. If you sort out the problem immediately, you may save a lot of extra work, and I'm going to say in this case, and stress later. The reason for that is that if we leave these errors to the point where we're now having to go into production with an assembly, now we have to go back and sit and resolve 120 errors. You can understand how this can become very urgent, very stressful, and even can lead to delays in production. All right, so this is actually a very, very important topic that we're covering today. All right, a little bit about our presenter. I think most people will know Reginald Mngelo. He's a senior application engineer at Product One. He's been with us just over 7 years. Before that, he has 5 years experience as an engineering technologist. He currently works on our support desk. He does our services delivery on the CAD side, and he's a trainer for Creo and Arbitext. so he has quite a bit of experience working with assisting customers in resolving issues. Reginald's not able to be with us today. He was called in to present a training course on short notice. So what he has done is he's recorded his session for us. So we're just going to play through the recording, but obviously there will still be people available to answer any questions that do come up at the end of the presentation. So I'm going to then start his recording.
Thank you, Michelle, for the introduction. Good morning to everyone, and thank you for joining today's webinars. So let's have a look at failures that happens because of a lost reference. This is a very common problem that happens in an assembly. You've got features such as squelched datum features that is referenced, which gets moved or deleted. So if you look at this image on the right, so you've got a plane that has been created, and this plane was was created using the axis as a reference. Assuming that someone comes tomorrow and delete that axis, that means that this plane is going to be affected. So the feature referencing it definitely will get affected, similar to the plane here. This will have a knock-on effect. So sometimes a failure can look small, but it can create a knock-on effect whereby one failure could affect maybe hundreds or thousands of parts within an assembly. So placement errors. So placement errors can happen because of different reasons. So sometimes it can be because of an invalid constraint. So for example, if I create a shaft and then I've maybe referenced it within a hole, but at the same time I say, okay, that shaft must be, for example, referenced to another hole that is not coaxial to that one. It will be impossible because they don't share a common axis. So that will make it an invalid constraint. Some of the things that could happen could be that your references are lost. Okay, so you can use the reference viewer in Creo to actually see the different parts of your parts. So to see, okay, what are the parents, what is the current model or feature that you are referencing, and what are the children, and it will show you if there are some that are missing, or for example, if there are some references that are missing, and then you can actually identify where they are missing. So sketch failures. So sketch failures, a common problem of sketch fail could be your references are missing. So I've referenced maybe a certain edge or certain surface, and that surface is no longer there, or maybe that plane is no longer there. So within the reference dialog box in Sketch, you can use it. It will specify which reference is the one that is failing, and then you can replace it accordingly. Sometimes it can happen because your reference is outdated, or because your reference has been suppressed. Okay, so the reference dialog box will show you which features or references are the ones that are missing, and then you can update those references accordingly. Secular reference. So we're going to be looking at an example like this today. So secular reference could happen because it's a violation of a parent-child relationship. So we're going to be looking at an example. So for example, I'm having two plates. Within those two plates, two of those plates, they've got two bosses. And then with those bosses, I'm using them as a reference to create holes on another plate. And then what I do an edit the definition of the plate with the holes. And then I say, okay, use those holes that were created referencing the boss to constrain on the parent one or on the other plate. So now it creates a cycle, and then when it creates that a secular reference, and then it's going to give you some problems. So this is something worth looking into when you actually face it right away. Import. So we're going to be looking at some import, also some best practices. Sometimes it happens that you are getting a part from another CAD software, and then when you get that part, it's not created it's not created using Creo or maybe another software. and then you want to import it. Someone could be working in inches and you are working in millimeters, so you want to try and import according to your start part, such that things such as your planes, your axes are imported correctly or accordingly. It actually makes it easier so that all your parts can be correctly aligned properly, especially if you want to do things such as constraining them, getting things such as your planes, your axes accordingly. It will help a lot. Regeneration failures. So regeneration failures could happen because your assembly does not regenerate. Some parts in an assembly have warnings, or some they've got errors. Okay, so and then you can use this option insert here to identify the parts with issues. So if you drag it up, all these parts below it, they are suppressed. So that means that if there is a failure or there is a regeneration failure, it means it can be any of these parts above. So you do it step by step. You start from the top, you go all the way to the bottom until that problem gets resolved. Okay. So we're going to be looking at a demonstration. Within the demonstration, we're going to be looking at a V8 engine that we got from GrabCAD. So we appreciate GrabCAD for making it available for us to use. So we're going to be looking at the different things such as your different sketch failures, secular placement, region, imports, native files. So let's get straight to the demonstration. So as I've mentioned, we are having an V8 engine. So firstly, on your status bar here, you can see we've got 2 regeneration failures and some outdated placements. So let's look at the first one, which is going to be the sketch, the one that we're going to be interested in. I'm going to select this component, and then I'm going to open it separately. Within that, there is a failure that's happening here. So you can see here that there is a failure. Because there is a failure, I can edit the definition to find out what's the failure. But before I do that, if I go to the regeneration failure, I go to that, I get some feature information just to better understand why is the failure. Could not find the references belong to this feature. So that means that there are some references that are missing. Fine. Let's see if we can resolve that. We're going to edit its definition and then go straight to the sketch. Now, we can see here that there is a point here, and this point is red. Could mean that it's actually missing. The software can no longer find it. So the reason why this one is red is because the one that it was referencing has been suppressed. Sometimes it could be that it is deleted. So I can replace it with another one, the one that is new. You can see how easy it is for one to replace some references. So after we've replace those references, now you can see that that sketch gets updated accordingly. So now our shape has been reconstructed, so our geometry has been created. There is no more failure. Now what happens if I'm in a situation, I'm going to this part on this side here, and then I realize, all right, this one is cylindrical, but we want to change the shape, give it like some polygon shapes kind of. So what we will do here, I will select that feature that was used to create that one. We're going to edit its definition. So while we are within sketch mode, okay, we are interested in making some changes within this one. So firstly, we're going to create a palette. So we want to get maybe an 8-sided octagon for now. Okay, and then just make sure it's in the center, and then we can scale it accordingly. Let's just scale it accordingly. I'm gonna scale it dynamically until maybe we get somewhere here. Okay, I'm happy with that, and then I'm gonna just finish the sketch. So sometimes failures can be created unaware. Sometimes you find that you are deleting something not knowingly what can happen. For example, if I select this circle here and then I click delete, it's giving me a warning showing that this entity is referenced by other features. Continue. So what is happening here is that this circle and this cylindrical shape here, there is a round that is referencing it. So if I delete it, that means that that round is going to be affected, right? So that means that I am creating a failure. So what can one do then? So what you can do in this case is that I can say, okay, I want to take this, I want to replace it with that sketch and make sure that all the properties or all the stuff that have been referenced on the cylindrical surface, now they're going to be shifted on this one. So why is this important? This is important because now this one will not fail. That means that those rounds that were on the cylindrical shape, they will be on the shape, and then also your part will be reconstructed correctly with no failures. So sometimes failures can be prevented ahead of time. Okay, so you can see now the round that I was talking about, there is a round here, and then that round is referencing the shape. So you can see the different things that we have done regarding this one. Okay, let's switch back to this one. What about if we are looking at some placement error? So this is sometimes a common problem, especially when you are referencing different planes or surfaces, and then for some reason it gets moved unaware. Maybe you are working on it, maybe another engineer works on it, and then he changes some stuff, and those changes can then affect your placement. So let's have a look at an example here. So you've got the AC component, which is our assembly that we are interested in. So if I edit its definition, so we are having a problem here. Okay, you can see the problem that you're having is that we are looking for that within AC component there is a DTM4 plane that is not that it's looking for. So if we expand it, you can see here this DTM4 is suppressed. So as you know, when you suppress something, it's not part of the regeneration cycle. It's as if like it's actually not existing at that current moment. It's not considered even if there is a regeneration that is taking place. So now we can see that, okay, this is a parallel constraint. So that means that we are looking for a surface or a plane that is going to be parallel to this one. So for us to fix that, we just give it a new reference, and then when you give it a new reference, that problem is solved. Okay, sometimes it might not be as simple as this one, so you just have to understand which references they are looking for, or the software is looking for. Some of the time those references might be deleted, so it might not be even easier for you to find them because they are gone. And you can see here that our placement is red. So let's see what happens after we fix it. Okay, so that part is now solved. It looks to be okay. So what happens if I want to import something? So let's say I want to import a part here, and this part has been created in another native CAD software. So in this case, this part has been created using a step file. So we are interested in using the manifold. So this is just one of the best practices that we recommend, is that use your current profile. So for example, use an import profile when you're importing stuff such as step files and other files as well. So you can browse your start part template, and then after you've browsed your start part template, you will say use template. So what that will do is that if I'm importing a part, it will use my template that I'm using in my workplace to actually create a new part. So this will just make things a little bit easier for you. Okay, let's have a look into this. So now we are using that template. So what we are interested in doing is that we want to then align it properly. So here it is. So we're going to move this part somewhere close by here. We want to align it using that hole there and this hole. We're going to align it using that hole and that one. Lastly, that surface there, query select the back surface there. Then we're going to make it to be coincident. Okay, and then after that, then that is fine. Let's have a look at if I open it just a bit. So if I'm opening it separately now, so one of the things you can look at is that you can see there is the right plane, there is my top plane, my front plane, and then my different excesses. So sometimes it happens that, okay, this part might be failing. So there is an import profile where you can go to edit the definition. And then within that, you can interrogate this further, use information such as import data doctor. So with this one, and then you can do things, check such as your geometry. If there are things that are overlapping or there are some surfaces that are not properly closed, you can do a lot of things within here, the import data doctor. So that is where you typically fix a part, for example, that has got a problem. Sometimes it happens that, okay, when you import this part, actually it's not giving you, it's not a solid part. And one of the ways to find out is that if you applied material on it and it does not give you the volume or the mass properties, that means that it is not solid. Okay, so that is the next one. So going back to our main assembly, let's have a look at a situation whereby I'm creating a circular reference, but as I'm creating that circular reference, maybe unaware that, okay, I'm actually creating a circular reference. So now, what do I mean by that? Okay, so let's have a look. So we are interested in this part which is called the oil pan. So with this oil pan, what we're interested in doing is that we want to create some holes, but we want to reference the V block on those holes. So let's have a look at what we're talking about. So I'm going to select this, that part, and then I'm going to activate it. Now, so we want to create these holes in the context of this part. We're going to create an extrude. Okay, so after we've done that, what we're interested in doing is that we want to create some references. So let's have a look and see if we can select some references. So firstly, just to make things more easier for us, we're gonna make it to be hidden line. So we are interested in adding maybe that reference there, and then just zoom it in a bit. We are also interested in creating that reference there. Okay, fine. Those are the references we've used, which are for the other part, not the one we are working on. Now, what we want to do is that we want to create those two holes here. Okay. And then we also want to create the hole the other side there. Then you will see now how we will create, how the circular reference will be created. All right, so we're gonna remove the material, and then everything is fine. We're gonna activate the main assembly, so everything is okay. Now another engineer comes, he's starting to work on this model. He interrogates how this part was assembled to the main assembly, so he decides to make some changes. I do the edit. I edit the definition of the placement, and then I say, okay, let me just delete the current constraints, the ones that are created. I want to create my own. Remember, before I do this constraint, firstly, these holes here were created using that one. So that means that without this one, they were not going to be existent. Secondly, now I'm using the same holes that were created using this one to reference them. So I'm actually creating a cycle. So you use this one to create this one, but at the same time I use this one to reference that one, and then it creates a loop or a cycle. So let's have a look. I'm going to select that surface there, align it with that one. I'm going to select this one, and then I'm going to align it with, I just want to make sure I'm aligning it with the correct one. I'm going to align it with this one. Lastly, I'm going to select that surface, align it with this one. Okay, everything looks fine. Creo is happy. And then after Creo it's happy, and then everything seems to be okay. All right. And then I'm going to click OK. Okay. Oh, oops, there is a problem now. It does show you that, okay, there is a circular reference. So if I go to my circular reference in Creo 9, you can then be able to see the circular reference report, which was previously not part of this dialog box. You had to go to the working directory. And then it does show you which component where it's happening in the V8. Okay, and then this circular reference is happening, it's as a result of extrude 1, and then with that it gives you the ID. So that is the cause of that. So this can really cause some problems for you, so you typically don't want that. So if you've added things such as your feature ID, your feature numbers and so on, so you can right click here and then within your 3 columns enable, for example, maybe your feature ID and so on, so that you can be able to search accordingly. So if you come here to your secular reference, the number that we are interested in, if I go to that one, you can see here it is feature ID, it's 18661. So if I come here and say 18661, the software will directly point me to say, okay, this is the extrude that is creating the problem. And then, so what you typically do, and then you have to go and interrogate and find out what happens. So again, that is one of the ways whereby a secular reference can be created. And to fix that secular reference, it's better than that you delete you reference this hole using other surfaces, and then not using the ones that were actually used to create those holes, and then that will then solve the problem, because we don't want to have circular references. So that brings me to the end of the demo. So going back to the PowerPoint, just to summarize. So what is the conclusion that we have here is that fixing a model alias saves you some time in the long run. Okay, failures are usually linked to other parts. So how you build your parts, how you put them together is important. Use the best practices as early as possible. It's one of the workshops that we do, whereby we offer this workshop to assist customers so that they can use the best practices, so that from the beginning they will know how they should assemble their components and how certain failures can be prevented. Regenerate a model before you check in to see if there are any failures. So this is important, because sometimes you can check in a model, but if you have not regenerated it after you've checked in, it can create some problems, and then those problems can have affect other systems as well, such as your ERPs and so on. Thank you very much for watching this webinar. I'm now gonna hand over to Ross.
Okay, great. I hope everyone got something out of that session that Reggie's put together for us. Of course, you can always reach out to our support desk if you've got a question around why something is failing, and get some input on how you can actually fix those types of failures. So please don't forget about our support desk. And yeah, if there's any other questions, any other solution advice that you need, please reach out to info@prod1.com. And of course, you can also go check out our website. We've actually just recently updated our website, a brand new design. It's, I think, a much better improvement over the last one. You can access it on your phone now as well. It's mobile friendly, so much easier to use. So please go and check that out if you haven't seen it already. And I think with that, then we'll close out the session. Thank you everyone for attending today, and we look forward to seeing you in the next one. Thank you.